In this short demo, we'll have a look at how you can configure the Anybus communicator CAN. The gateway works as a translator between an industrial network and any industrial device enabled for the CAN protocol. I have downloaded the Anybus Configuration Manager for the communicator CAN from anybus.com and installed it on my computer. First, I need to choose which controlling network we're using. I select Profibus DPV1. The help pane at the bottom continually provides me with information and help on what I see in the top pane. In Communicator, I set up general settings for the gateway. For example, I can enable or disable the control status word and set up a transaction live list. The transaction live list is useful for the PLC programmer since it enables each transaction to include 1 bit of monitoring information. In this example, I state that I want to map 32 transactions, which means that 4 bytes will be monitoring information. I now move on to configuring the CAN network. I start by specifying the bit rate, which I set to 1 megabit. The bus off action is available only when we're not using a control status word. This determines what happens if the CAN traffic is jammed. Should the communicator reset the CAN transceiver and start up again, or take no action? I also choose whether I want to use 11 bits for CAN 2.0A or 29 bits for CAN 2.0B. To start creating the protocol on the CAN side, I right-click and choose Add Group. In my group, I can start to add transactions for the devices I want to connect. Let's say that this is a group of machines that I want to call Machine Group 1. In this group, I have a drive that I want to send information to and get information from. Therefore, a query response transaction is a valid choice here. I name the transaction Drive 1 and can start to set up general settings for the queries and responses from the drive. I can specify what should happen if the network goes offline. I can also set up the update mode. I select On Data Change, which means that the communicator will only send information if there are any data changes from the PLC. This can save me a great deal of bandwidth. I can now start to add CAN frames, in which the actual I/O data is contained. This is how I want to set it up. In the query to the drive, I want to add a double word constant, consisting of 4 bytes and a data object of 4 bytes containing the control value for my drive. This makes up the entire CAN frame of 8 bytes. To do this in the Configuration Manager, I right-click and choose Add Frame. I set a CAN identifier for the frame. Let's say 601. I add the double word constant and type in my value. I then add the data object, which we set to 4 bytes. Consequently, this CAN frame consists of 8 bytes, 4 bytes in the double word constant, and 4 bytes of data. This data is read from the internal buffer area on the address I can see here. The data originates from the PLC. Moving on to the response, I want to do the same thing here. Add a double word constant and a data object of 4 bytes consisting of the response from my drive. In the Configuration Manager, I add a frame and set the CAN identifier to 581. I add the double word constant and specify a value. We also add the data object with 4 bytes. This data is written to the internal buffer area on the address I can see here. The data is also transmitted to the PLC. I have now set up my drive and can move on to the next device in my Machine Group 1. This is a barcode scanner, so a consume transaction is fitting here. This means that the gateway only receives data from the node. We name this transaction Barcode Scanner and move on to configure the transferred data. I add a CAN frame and set the CAN identifier to 181. We then add a data object, which is 4 bytes. If the message from the barcode scanner consists of more than 8 bytes, which is usually the case with barcode scanners, I can fragment the message by adding more CAN frames. I've now finished the configuration for the group called Machine Group 1, and I can save this configuration to my hard drive. I can also click Download Configuration to send it to the Anybus Communicator CAN module. The module will now restart and initiate the uplink network according to the new data settings. This is all I need to do to set up a communication protocol between an industrial network and a device with a CAN interface. But there are also a number of useful diagnostic tools that I can use to monitor the transactions. In Monitor Modify, I can see incoming and outgoing data for the transactions I've set up previously. By selecting the Modify checkbox, I am able to handle the out data for all the query and produce transmissions instead of the PLC. CAN Line Listener allows me to see a log table of the CAN frames that are being transferred on the CAN network. In Address Overview, I see a graphical overview of the data addresses for my drive and barcode scanner. The data is color-coded, and I can see which data that belongs to each transaction, and if there are any collisions. Diagnostics is another useful tool, showing me the current status of the network. The last tool we should look at is Options. Here I can, for example, password protect uploads or downloads to the communicator. This is useful if I want to avoid people accessing my CAN configuration or avoid people from downloading unauthorized transactions to the network.